Hi again, this is Mrs. Lemoyne, and today we'll be doing Illustrative Math, Grade 5, Unit 3, Lesson 17, Fraction, Multiplication, and Division Situations. We're going to be solving problems involving multiplying and dividing fractions, which is what we've been practicing for the last 2 units. All right, we'll start with a number talk. 5 divided by 1/6. So I multiplied 5 times 6, and I got 30. And I started with 5, so I knew that I would end up with an answer that was bigger than 1, right? And I could draw that if I wanted to. 1, 2, 3, 4, 5, and divide them into 1/6s. And how many 1/6 are in each one, right? There's going to be 6 in each one. So how many 1/6s are in 5s? There are 30 of them. All right, let's move on to our next one. 5 times 1/6. 5 times 1/6 is 5/6. And we know that, right? 5/6. Because we multiply the whole number times the numerator and keep the denominator. All right, this one's a little bit more difficult, but we've been working with this, right? We know that if we start with a fraction, we're going to end with a fraction. So I know that my numerator is going to be 1, and then I'm going to multiply 5 times 6, and I'm going to get 30. So that's like asking how many 6s are in 1/5, right? So if I have one, gotta get 1/5. 1, 2, 3, 4. So here's my 1/5. How many? 1, 2, 3, 4, 5, 6. How many 6s are there? There's going to be 1/30 of them. All right. Let's erase that. So we said that this one, sorry about that. We said that this one was 30, this one was 5/6, and this one was 1/30. And again, I remind myself from the last lesson that if I start with a whole number, I'm going to end with a number that's greater than 1. If I start with a fraction, I'm going to end with a number less than 1. All right, now we're going to multiply 1/5 times 1/6. And I know that I just multiply the numerators. 1 times 1 is 1, and 5 times 6 is 30. How are the last 2 problems related? Well, dividing by 6 and multiplying by 1/6 give the same result. So if I am dividing by 6 and multiplying by 1/6, I'm doing the same thing. So 1/5 divided by 6 is the same as 1/5 times 1/6. I'm going to get 1/30 for both of those things. So that's interesting, right? If we divide by a whole number, we can flip it and make the numerator 1. We call that the reciprocal. So this is the flip of it, right? Then we know that what we're doing. Okay, let's move on to our first activity, info gaps. Info gaps. So that's where you get a problem card or a data card and your friend and you work together by asking questions and solving the problem. So we've done info gaps before, so I'm assuming that you learned how to do this already. If not, you can take a moment to pause the video and read the instructions. But I'm going to go ahead and get out of this program and go to my overhead so that we can start solving these problems. So here is problem card 1. Elena is covering a floor with a rectangular tiles. How many tiles will Elena need to cover the floor? So I'm going to think about my floor like this. That's the floor in my room that I want to cover with tiles. And then I'm going to ask myself, okay, what do I need to know to be able to cover that with tiles? Well, I need to know how big is the floor. Another way to write that is, what is the area of the floor? Okay. Then I'm going to have to know what the area of each tile is, right? Sorry about that, that's loud. The area of each, how big is the tile? What's the size of the tile? How big is each tile? So those are the questions that I would ask my partner. Remember, you have to ask specific questions for her to give you answers, right? So how big is the floor? And then she would ask, why do you need to know that? Well, I need to know the area of the floor in order to know how much I need to cover. And I need to know the size of each tile in order to know how much each tile covers, right? Because I think the question is, how many tiles will Alina need to cover the floor? All right, I'll put that up here. And I'm going to go ahead and show the data card. But remember, in class, you would have to ask for these answers, I'm sorry. All right, the first thing it says is that the floor is a square. Oh, that's important because that means that the length and the width are the same number, aren't they? Then it says the length of one side of the floor is 8 feet. So that means this is 8 and this is 8. And over here it says the area of the floor is 64 feet. So if I multiply 8 times 8, I know that the area is going to be 64 square feet. All right, let's put that aside for now. Now I know how much flooring I have to cover. What do I have to work with? Well, I have tiles, and they're not equal sized, right? So one side is going to be half a foot. Let's do the half foot here since I drew it like that. And then one side is going to be a third of a foot. So in order to make this a whole foot, I'm going to need 2 of them, right? So that's going to make 1 foot. And in order to make this a whole foot, I'm going to need 3 of them, right? 3 1/3 make 1 foot. So in order to make a square foot, a foot by a foot, I'm going to need how many tiles? I'm going to need 6 tiles. But let's put our halves down here. So a half foot and a half foot, that's going to make 1 foot, right? So if I do 2 tiles per foot, that's 2 tiles times 8, I'm going to need 16 tiles along the bottom. So this length right here, I'm going to need 16 tiles. Going up, remember I need 3 to make 1 foot, 3 tiles to make 1 foot, so I'm going to have to do 8 times 3, right, is 24 tiles. So 16 by 24 tiles, right? So that means I'm going to have to multiply 16 times 24. Another way to think about it is, I know that it's going to take me 3 to make a foot there and 2 to make a foot there to make 1 square foot. I know it doesn't look like a square when I draw it, but it is 1 square foot. How many square feet do I need? Well, I need 64. It took 6 tiles to make 1 square foot, 6 tiles for 1 square foot. How many would it take to make 64? So could I just multiply 64 times 6? I think that's easier than multiplying 24 times 16. So I'm going to do that. So let's see, do I have room up here? I'm going to do it in the box. Here we go. So I need to cover 64 square foot, and it takes 6 tiles to cover 1 square foot. 6 times 4 is 24. 6 times 6 is 36, 37, 38. So it's going to take me 384 tiles to cover this floor. 384 tiles to cover that floor. And I could have found that just as easily by doing 24 times 16. All right? Good job. All right, so I'm going to bring that to my teacher. She's going to check my work, and if it's correct, I get to go on to problem number 2. Problem number 2 asks, Mai is covering part of the bathroom wall with rectangular tiles. How many boxes of tiles did Mai need, and how many tiles will she have left over? Well, again, I'm going to need to know the area of the bathroom wall, right? Bathroom wall. Area of the wall. I need to know the size of the tiles. And this one's weird because it's not asking me how many tiles, it's how many boxes of tiles. So I'm going to need to know how many tiles are in a box right? How many tiles are in one box? Is there anything else I need to know? How many tiles will she have left over? I think that's it. So again, I'm going to picture my wall. And the first thing I'm going to ask my friend is, what is the area of the wall? What is the area of the wall? And she is going to say, let's show our little data card. The wall space is a rectangular that is 8 feet long and 6.5 feet wide. 6.5 feet wide. All right, so that would give me the area. I could multiply that out and find what the area is, but I can also figure it out just by finding out how many tiles will go here and how many tiles will go there. So I'm going to wait on that. So I'm going to ask her, what are the size of the tiles? So I found out the size of the wall. I need to find the size of each tile is 1 foot long. So here's my tile. It's 1 foot by 1/4 foot. So that's going to be really tiny. So 1 foot by 1/4 foot, right? So how many tiles would it take me to get to 1 foot on this side? It's going to take me 4 of them. 2, 3, 4, right? So to go along this bottom part, how many tiles will I need to go along the bottom? I will need 8, because they're each 1 foot long. So 1, 2, 3, 4, 5, 6, 7, and we can move this along a little bit, widen it, 8. Okay, so I'm going to need 8 tiles across the bottom. I'm going to pretend they're all the same size. And then I'm going to need how many tiles? I'm going to need 4 for each foot that there is. Well, if I need 6 feet and I need 4 for each foot, I'm going to do 6 times 4 equals 24. And then I need 1/2 of a foot. Well, that's going to be adding 2 more tiles, right? Because that's going to be 1/2 a foot plus 2. So I'm going to need 26 I'm going to need 8 across the bottom and 26 across the side. So we could just multiply to find out how many tiles I'll need. I'm going to do, this is 24. 26. I'm going to do 26 times 8, and that's going to tell me how many tiles are going to go across the whole thing, right? 8 times 6 is 48. 8 times 2 is 16, plus 4 is 220, 208. All right, so that's how many tiles I need, but that's not what they asked, is it? So if I go back over here to look at what they asked how many boxes of tiles will I need? Well, that means I'm going to need to know how many tiles are in each box. I didn't write that down right. How many tiles are in each box? So that's where I'm going to ask my friend how many tiles are in each box. And when I look at the data card, I see that there are 42 tiles in each box. So now I have to say, okay, how many 42s are in 208? So that's a division problem, right? How many 42s are in 208? Well, you may not know how to do 2-digit division, but that's okay. We can also use multiplication, right? So I'm going to guesstimate. I'm going to say, how many 40s are in 200? Well, I know that there are 5 4s in 20, so let's start guessing with 5. So I'm going to multiply times 5. I'm trying to get as close to 208 as possible, right? So 5 times 2 is 10. 5 times 4 is 20, plus 1 is 21. So if I had 210 tiles, would that be enough to cover my room? Yeah, because I only need 208, right? So this was the amount of tiles in each box. This is 5 boxes will give me 210 tiles. So what was the question I was trying to answer? Let's go back to that question. How many boxes of tiles does mine need? We need 5. How many tiles will be left over? Well, if I needed 208 and I have 210, that means I'll have 2 tiles left over. All right. That was a really complicated problem, and there are other ways that you could have solved it, but everybody should get the same answer of 5 boxes of tiles and 2 tiles left over that we won't need. We could have those tiles left over in case we break any of the other ones when we're installing them in our room, right? Okay, let's go back to our slideshow. Here we go. All right. So what was your answer to the problem about tiling the floor? Well, our answer was 384 tiles, because we figured out how many tiles would go across the bottom and how many tiles would go across the side by knowing how many tiles there were in the room. Okay? Oops. Did you use multiplication or division to solve the problem? Well, it depends on how you decided to solve it, right? I used multiplication. I used multiplication to solve it. I did 64 square feet times 6, and I got 384. So I used multiplication. How did you solve the problem? Well, we just went over that. What was your answer to the problem about tiles for the wall? So remember, our answer was, let's get this one in pink, 5 boxes with 2 tiles left over. Okay. How did you know whether to use multiplication or division? Well, we used multiplication and division, didn't we? And we had to know because the wall was a certain size and it was not a square. It was, let's see, what was it? 8 by 6.5. So we had to find out how many tiles would fit across here and how many tiles would fit across there. And then we had to multiply that, right? We found that there would be 26 across here and 8 across there. So we multiplied 26 by 8 and we got 208 tiles. And then we kind of had to do division to find out how many boxes would get us close, by how many boxes of 42 tiles each, which is really division, to get us close to 208. So we really said 208 divided by 5, 42, sorry, 42. And it was close by getting to 5. And we had to go over, right? Because if we went under, we wouldn't have enough tiles for the room. So we just talked about how we solved that problem. And now we have a new problem to solve. If 11 grams of rice weigh 1/3 gram, how much does each gram weigh? What I'm noticing about this problem is this is the total weight, right? And this is each grain. So I think I'm going to have to take the total weight and divide it by how many grains we have to find out how much each grain is going to weigh. And remember, when we did the warm-up, we said that dividing by a number is the same thing as multiplying by its reciprocal. It's reciprocal. I did not write that correctly. There we go. 11. So I could just say 3 times 11, or 3 times 11, or 1/3 times 1/11 will give me 1/33 of a grain. And that does make sense, right? Gram. Why did I write grain? Sorry, girls. Gram. 1/33 gram each, right? Each rice grain. So 1/3 divided by 11 is the same as 1/3 times 1/11 is 1/33. And that makes sense because if they all weigh 1/3 of a gram, then I know that whatever they weigh in the end, each grain is going to be less than that. It's going to be less than that. And I know that when I start with a fraction less than 1, I'm going to end with a fraction less than 1. All right, let's look at the next one. Mai's road is 9/10 mile long. She ran 3/4. There's that special word of. That special word of means to multiply. So 3/4 of the length of her road. Well, what is the length of her road? 9/10. So we can say 3/4 of the length of her road was 9/10 of a mile. And I know in multiplication, I just multiply it across, right? 3 times 9 is 27, and 4 times 10 is 40. So 27/40 of a mile. All right. If each tennis ball weighs 2 1/16 ounce, how much do 9 tennis balls? So if I have 2 1/16, that's 1 tennis ball. I need to know how many 9 are. I'm going to have to add that's 2 tennis balls, 3 tennis balls. Well, remember, with a repeated addition, I'm going to have to do this 9 times, right? I don't want to do that. So let's do 2 1/16 times 9. Now, in the last unit, I learned that I could break this up just like I did in primary school. I can put 9 here times, and I can break it up to 2 plus 1/16. Do I remember doing that? So 9, and these numbers are awful close together. So let me move this over a little bit so you don't get confused. This is times 9. So 9 times 2 is 18. And 9 times 1/16 is 9/16. Now I just add those two together and I get 18 9/16. That is how much 9 tennis balls weigh, and that's ounces. All right. So that was a little practice about multiplication and division. Okay, let's do some synthesis. How does this equation represent the first equation? Well, remember that the grains of rice all weighed 1/3 gram, and there were 11 grains. So to find out how much each grain weighed, we divide, and in division, we can also think of it as multiplying by the reciprocal. So we get 1/33 gram, right? Because I also know that if I start with a fraction, I have to end with a fraction less than 1. All right, 3/4 times 9/10. How does that represent the situation? So 3/4 was how far she ran, and we knew we had to multiply across, and so we got that answer. All right, what is the relationship do you see in these problems? Well, there is a 5 and a 6 in each expression. Some of the equations have multiplication and some have division. Some have a whole number value and some have a fraction. Okay, what do we know about the relationship between multiplication and division? I can sometimes find the value of division expression using multiplication. And we did that when we did this one, right? We could say 5 times 6/1. We could say 1/5. Oops, I have to think about that. How do we know the relationship between multiplication and division? Because we can relate those two, right? The value of division expression, we can find it by using multiplication. All right. All right, what relationships do you see in these problems? I see that there is a 5, a 6 in each expression. Some of the expressions have multiplication and some have division. Some have whole number values and some have fractions. You can take a minute to describe the relationship to your partner. What do we know about the relationship between multiplication and division? I can sometimes find the value of division expression using multiplication. And that's why these two expressions have the same answer. I can divide by 6 or multiply by 1/6. That's how that can help me. All right, let's move on to the cool down. A container has 2 cups of milk in it. 2 cups of milk. How many 1/4 cups of milk are there in the container? So I'm going to draw the container as cups of milk. Oops, sorry girls. Let's go back one. There we go. And there. So here's 1 cup of milk, and 2 cups of milk, and they're in the same container, right? And how many 1/4 cups of milk are in each container? Well, I'm going to cut them into fourths, and here's a fourth. I'm going to cut this one into fourths, and there's a fourth, right? So how many fourths are in this one? Well, I can see that there's 1, 2, 3, 4. So there's going to be 4 in this one. So how many cups of milk, how many 1/4 cups of milk are in 2 cups? I would say that there are 8. 8 1/4 cups of milk in each. I could also write that as a division equation. 2 divided by 1/4 is 8. Remember, when I start with a whole number, I have to end with a whole number. And that's the picture that would help me decide how to do that. All right, my last problem for today. A container has 2 cups of milk in it. The container is 1/3 full. How many cups does the container hold? Well, again, I'm going to draw a picture. So my container has 2 cups of milk in it somewhere, right? But it's only 1/3 full. So let's cut it into thirds. So here are my 2 cups. How many cups does the container hold? If it was full, how many cups would it have? Well, it would have 2 cups here, 2 cups here, and 2 cups here. So that would be 6 cups. All right. So that could also be written as 2 divided into thirds is 6. All right, that's it for today. Thank you, like and subscribe, and I'll see you in the next one.